Okay, so we're going to take a look at how to build a series circuit on a breadboard. And this is what you'd normally do in the lab, but online classes, we're going to use a piece of software called Falstad. So first, I wanted to show you this and kind of explain what a breadboard does and how it works. And as soon as I can get this video started, we'll talk about that. And I'm just fast forwarding. This is on YouTube. But anyway, all right. So I'm going to pause this video. And what you see here, you see a bunch of holes in series of 5 in a row. Generally, anywhere you see 5 this way, this one, for instance, I'll start here. F is connected to G, which is connected to H, which is connected to J. And that's only for this row. It's really a row or a column, depending, I guess the orientation now has it in a column. But this particular column, all of them are connected together. Now this particular column, all of these 5 are connected together, but they're not connected to these 2. Now looking at these rows up here, it's a little different on these little side guys here. They're connected generally at least halfway down, if not all the way down. So these 5 are definitely connected, but they're also connected to these 5, and they're also connected to these 5. So what this does is it allows us to take these individual components and resistors here, or what we've got here, and hook wires and hook components and do things to it that we can do without having to wire these things together physically, tying them together or soldering them together on a circuit board. So it allows us to test a circuit pretty easily without having to exert a lot of effort to do that. If you notice, he's got this in the one marked positive right here. So this entire row all the way down, because these are unique and notice the spacing, that's one way you can tell, are connected together. So we're coming from a DC power supply over here, and we're going down this row that's all interconnected underneath here into this resistor. And then notice these 2 are in the same column, so they're physically tied together out of that resistor. And notice he put a red jumper here to carry it back to this black wire. Now he's going to kind of draw that for you. He'll let you see the schematic as it goes. There's your positive power source, there's your negative, there's your 2 resistors, and there's your DC power source. So again, pretty easy to follow. We're just bringing in positive here, bringing it over to that resistor. These 2 resistors are connected together. This jumper forms a path back to right here. And you're going to see Falstad looks a lot like what he just drew. And the nice thing is we can build virtual circuits and play with them as well. So I'm going to let you, he's got misspelling error there, but he's got the right thing as far as this goes. And I'm going to let you see Falstad now. And those were just 2 1K resistors connected in parallel. Now how I found Falstad was just Falstad Circuit Simulator. I clicked on it and I get to it. There is a full screen version, which I prefer to this one. So I'm going to scroll down and click on full screen. And notice there's a run stop. Generally, you can start over and this thing won't stop itself, but just be aware that it might. So now we've got a blank palette here. So we're going to we're going to draw a source. And we're going to do a 2-terminal voltage source right here. So I'm going to draw this away. And if I move my mouse and hold it again, it's just going to draw another one. And so to keep that from happening, and I'm going to hit escape. I'm going to right click on this one and get rid of it. And if I want to move that one, I can wait till it turns blue and move it down. So there's that same power source. Now we don't have the wires running back to it because this is the source. And now I'm going to draw a couple of 1K resistors. And I think this defaults to 1K, if I'm not mistaken. We'll see. Yes, it does. Now notice these dots. These dots represent connections. So if I come here and draw another 1K resistor, they are not connected together and they are not connected to this source. Now I'm going to come over here and do draw, add wire. And I've got to make sure that I'm clicking on the dot. I can't click below the dot and it'll look like I'm connected, but I'm not. Notice they're red. That's showing they are not connected. But I can move it up to where they do overlap, and now they are. So make sure you literally connect the dots. So I'm going to draw a dot I'm going to draw a line from that dot. I'm going to connect these two, connect these two. I'm going to come down to here, and I'm going to do this. So now you can see I've got current flowing. Now, I don't remember if he had a voltage source there. We'll just say it's 10 volts. Why not? But I can right click on this and I can make it whatever voltage I want. So I'm going to say 10 volts. And now 10 volts of voltage, 10 volts is running, supplying the circuit, and current's running through. Now the nice thing about this thing is we can add test points. And anytime we add a test point, we're measuring from that test point to ground. Now the negative is grounded here, and I'm going to show you that. We don't have to put this here, but I'm going to. So there's our ground reference point connected to, actually it's, yeah, it is connected because I got a dot there. So if I come up here and I do a draw, and I choose, actually I'll show you how to measure across it with a meter. So I'm going to go to scopes. Sorry, it's under, I have to remember it's been a little while since I used this. We're going to go to add voltmeter. And what we're doing is just literally measuring voltage across this resistor, or that's what we're planning to do. Now, right now, I'm not hooked to that resistor. And I got to make sure I hit the dots, because there's one dot, and we'll find the other dot right down here. So I'm going to have to draw a wire to right there, and draw another wire to right there. Oh, I'm drawing, see, I forgot to hit escape, and I'm drawing more voltage sources, so it's confused a little bit. So let me do a Control Z and get rid of both of those. And we're going to go back to add wire this time and do it the right way. There we go. And there we go. Now notice that went from 10 volts to 5 volts, because until I hooked this second one up, it was referencing this ground point. But once I hook the second up, it's measuring the drop of this 1K resistor. So I'm going to hit Control Z, which backs it up, and I'm going to show you that if I come down here and connect to that ground, I still get the 10 volts that I was getting there. So that's actually what it was doing, and that's why we're seeing 10 volts there. But I'm going to draw, add wire, and we're going to connect one across this guy. And I didn't connect these two together, so it's still referencing ground. There we go, 5 volts. So I'm going to do the same thing here. I'm going to draw and go to outputs and labels. I'm going to add a voltmeter. I'm going to put it right here. I'm going to go to draw, add wire, and I'm going to connect it right there. Now notice they're dropping, this source right here is 10 volts. Each one's dropping 5 volts, and that's accurate, because the sum of the drops should equal the applied voltage. So if I come over here and change this source to 12 volts, they're each going to drop 6 volts. And they do, because they're equal. Now if I change the value of one of these, their drops are going to change proportionately. So I'm going to change it from a 1K to a 5K. And you're going to see I'm dropping 2 volts here. I'm dropping 10 volts there now, still 12 volts, but their proportions are different because their values are no longer equal. And so you can see that the drop across a resistance is proportionate to the resistor itself. So the higher the resistance, the higher the drop related to other resistors in a series circuit. Now parallel will change all of that here when you get into it. But this is the nice thing about these virtual circuits. You know, in the real world, I would want to cut this source off, and I would want to take out this 5K and put in maybe a 10K. But here, I can just right-click on it, say edit, and I can make it a 10K now if I want to. And there we go, 1.09 and 10.9, again 12 volts. I could change this guy to a 2K if I wanted to. So if I were trying to work to build something, whoops, I did an add scope, so let me do it. Control Z undoes whatever you did last. So I'll come up here and edit this guy, and we'll make him a 10K. We got the bottom as a 5. This is a 10, and look at there, the 10 drops twice as much as the 5, again, proportional. It still adds up to this 12 volt source. And again, if I change this 12 volt source, our drops are going to change. If I change that to 5 volts, I'm going to get 2/3 of it dropped here and 1/3 here. If I change it to 50 volts, I'll still have 2/3 and 1/3. It'll just be a different proportionate value there. So pretty neat to play with this. So all your experiments that would normally be done on breadboard can be done in here. There's some more advanced features you'll get into as we go along. But this is just a nice way of starting out. The other thing that it does have is basic circuits already installed. So if you're having trouble building something, you know, like here's one with resistors, that's a pretty complex circuit. But I could start taking this out and working with it. Let me see if I can find one a little less complicated. Here's series, parallel. Those are caps and inductors, so we're a little more advanced. So let's just go back to Ohm's Law. There we go. And these are two that are in parallel. But again, if I wanted to work with this one, if I wanted to kind of massage it, I could come over here and hit stop, and I could move, oops, escape because I'm drawing wires. Do Control Z and hit escape again, and I can move things around. And I can put this guy over here, and I can put this guy down here. Make sure I connect them up. I can right click on this and delete it if I wanted to. I can come in here and add a source. And so we'll add a voltage source to terminal. I'll put it right here. Turn it this way. For some reason, I just like the positive on top. It doesn't particularly matter. I can get rid of this. Get rid of that. There we go. And now I can just draw my wires. So I took a pre-made and just kind of massaged it a little bit, making another series circuit. And all that stuff to the left is just extra. Hit start, and we see we got current flow. And I can come over here and right click on this if I want to. So there's some circuits in here that kind of already have some pre-drawn. So if it's easier to work with one of those and just play around with it, massage it, that's fine too. But a lot of power right here in this little simulator at your disposal to do these labs. So there you have it. There's Falstad, and in addition to that, there is some help in Falstad. I'm going to go back to the there's some directions, and this will tell you some different things. And also up here, there's a complete manual that you can get. So a lot of information out there. Just a matter of knowing where to find it and applying it. So all of your labs that you have will be done using this Falstad. And of course, if you need help, please let us know.